Hello there gadgeteers, welcome to another video of Minoko's Gadgets. It's not really a video, it's a stream. Hello Hello there gadgeteers, welcome to another stream of in my channel. So today we're gonna be doing Lua 2D, Love 2D for the 6th time, and I think it's really cool. Horse. So we have Chris over here. He's like a long time viewer on this channel. Pretty good. So yeah. So in the stream, I upgraded my stream again. You can't really see this on the horizontal form of the stream. If you go to the vertical form, you can actually see, like, if you want to see the vertical form, just go to the vertical form right now. And what's cool about the vertical form is, like, hold on, let me just like put it to the main scene where VS Code is. If you go to like the vertical form, you see the file tree. If I'm not using the file tree, it would automatically make itself transparent so you can see more of the code. For example, if I go to some thing that has a lot of code in it, which is not here, yeah, like this one. If you go to somewhere where there's like a lot of code, and if on the vertical form, if it's not using the file tree, it would automatically make itself transparent. So the code below it you could see, right? Because it's transparent. But the as soon like if I go to like the file tree, it would make itself opaque. Is that a word? I think the word is opaque here. It would make itself solid, not transparent, and then you'd see that where I'm going with this. Okay, so let me just like close that, and yeah. Oh my god, I thought, wait, why can I? Okay, there you go. So hold on, I'm having difficulties in moving my windows. Okay, now we're in this scene, sheep pollution, which is really great. I think we're still in classes. Yes, I think obsidian. I think obsidian. Yes. What do you mean obsidian? Hashtag obsidian? So let's go. Whoa, what's this? Yeah, classes. I want to learn about classes, and let me just move my. I cannot really move this freely. Damn, that's like. That sucks. I have like a window right now that's like telling me who's chatting. Like I can see the chat, but it's really hard to move it around. Sometimes you cannot move it around for some reason, and I'm having like difficulties. Okay, so how about that? Okay, I can do it like that. So I think we touch a little bit of the classes, and I didn't understand what is it like about. So like let's try to like read it again, or let's just like, yeah, we need like a library for this one for some reason. And I actually imported the library, so it's here. You see this? This is the library, and it's kind of short. Like I was surprised that the code for this is not a lot. And I don't understand what it's trying to say. It's trying to say that we could use classes inside Love 2D, but they said that like hashtag obsidian, hashtag obsidian, hashtag obsidian, hashtag obsidian, obsidian. Do you mean like the markup language? Not the markup language. It's the software for creating notes with markdown. Yeah. What about Obsidian? I don't use Obsidian. I use like an app called Anytype. It's basically Notion, but it has features that Notion doesn't have. For example, it's completely offline, right? And it's offline. It's completely free. You can sync across devices. The devices could be unlimited, and you could share notes as a website and share it to anybody who wants it. There's like a lot of perks onto it. I will send you the video later, XDD. Nah, bro, mining low. Hashtag Obsidian. Oh. And Anytype is fully encrypted. So people couldn't read your notes even if they hack you. They need like an encryption key. Then they could read you or steal your password. I don't know. So Obsidian is cool, but like I don't really like that for syncing it's not free. Yes, it's free if you upload it to like Google Drive or Dropbox, but I kind of wanted the software that's like it works out of the box. It doesn't need Google Drive or Dropbox. Anytype just does it for you. And I'm using it currently. Send me that website, bro. Ah, sure. I can copy the link and paste it here. Can you? Yes, you can like go there. On Anytype, I put all my private information. So I can't like show you a window of Anytype. I could risk doxing myself. Like for example, I have like a note that has all my people's contacts, their address, their phone number, their birthday, every information. And like I have another one that's storing all of my cool websites. Actually, I can share the website. Yeah, I think on Anytype, I'm gonna like show you. What's cool about Anytype is that you can make a note online. You can share it to anybody, which is kind of cool. So, hold on. Can I share this? I don't know. Ooh, that's. I kind of want to share a website, a note. What can I share here? I don't know. Hold on. Let me like make a note. Random website. Sorry you cannot see this because I'm like doing things in Anytype right now. And then on random website, I'm gonna like copy and paste copy paste things. Copy and paste. All right, I copy and paste here. Random website. So I'm gonna share this on the internet. So random website publish. I'm going to publish it right now. So publish it. And then it's online right now. And then I can share this to any of you guys. I'm going to share it on the long form, the horizontal form stream. And if you guys click on this link, this is basically a note that I made that I shared through you guys. It's cool, right? Feel free to like visit the sites I put there because like some of them are really cool. Just like, for example, What did I put? I put like JSFXR. JSFXR is a really cool website. I can show you. JSFXR. It's basically like a website where you can create your own sound effects for games. For example, if I go to jump here, oh my god, that's really loud. Can I? Okay, the gain. Let me just turn it down a little bit. Yep. Turn it up, I guess. And then when you click on jump, you can like adjust the parameters. Would you look at? Ah, that hurts. Yep. It's similar. So Chris, you use like another website for sound effects? Can you like share it for me? I wanna like visit it. I'm just like, oh, that's cool. So as you can realize, you can just play with this and create your own sound effects, like the hit sound, and just like play with this a little bit, and then you got your own website. You got your own sound that you can download. So how can I download this? Like a copy code. What is copy code? What does that do? I don't know. So is there like a serialize? What's that? Deserialize. Open save. I don't know how to like download. Oh, you can download it right here. So hit hurt that wave, that WAV. You can like press this and save the WAV file. Okay, what else? What website did I put here? The flipping CSS loaders collection. Okay. Flaticon. Flaticon is like the best website for downloading, icons. It's basically my number one go-to. It's a really cool website because all of the icons are free. Like for example, if I want to have an icon, if I want to have the YouTube icon, I can go here and see and choose what I like here. For example, I really like this. I just click this, and what's cool about this is you can edit the color of it. Oh, I have to be like a registered user. But normally, if you're registered, it's completely free to change the color of this and save it as PNG. You cannot do SVG, but that's absolutely fine for me because like if you save in PNG, you can go up to 512 pixels. Wow. And it's literally my go-to icon site. For example, if you want like a home icon, you can just like go to home, find one you like, and for example, arrows. That's like for editing too. It's basically the best site for putting icons. Like he has everything. Like for example, Discord. There was not like a there was not like a situation where I didn't find icons from this site. It's crazy. And everything is free, but I think like I say everything is free, but you should attribute to the user who created the icon. Like if I go restart here, why did I put 7? And let's like, for example, download this. Let's free download it. it would like it would be happy if you um hey, remember you have to attribute B illustrations. So you need to attribute it to them. What do you call it? Credit? Yeah, you need to like credit them, or I don't know. You're gonna be dying. You're gonna get like sued. So, anyways, let's learn about classes. So now you are ready to make a class. Create a new file called rectangle.lua, and in my example, I'm gonna do circle.lua. So let me rename this because this is not a Lua file. I mess up. And inside of that thing, we do a rectangle, a circle in my case. Let me just like put like comments in the first 3 lines. This is like, I should do this because on the vertical form, if I put the code on the very top, it's actually like touching with my webcam and you couldn't see the code. So I'm just going to do this. Wait, I'm suing you for no reason. Why? If you watch uh if you watch my videos, like my long form videos, I used to like use the noun project. This noun project. It's basically the same thing as looking for symbols. You can look for symbols here, but I found out like Flaticon is far more better than the noun project. But I think the noun project is cool too. So let's just put circle. Oh, I realized that the first letter is big here. It's capital. Okay, and then we need a capital letter object. There's a keyword for object. I didn't know that in Lua. Extend of what is this? What am I writing? What is this? This is cryptic. Rectangle dot new and then self? What is that? What am I writing here? Okay, and then self dot test equals math dot random 1 to 1000. Okay, and then here everything will be explained, but first put this code in your main.lua. All right, so in my main.lua we have required classic, and below that we need to require the circle.lua. Circle. And then R1 is equal to rectangle. Okay. R2 is equal to rectangle. Okay. I accidentally spilled water. What the hell? Let me get like tissues. Self that explode. Guys, I got called. I'm sorry, but like I'm gonna make you guys on hold. So sorry. I'm very sorry. So my mom just gave me ice cream. So I have to eat this. So what we're gonna do right now, and let's read some comments. Okay. Let's read the comment. My comment to he left. Hello, I'm back. I'm back. So let me just like close it. All right. Hold on, guys. So what we're gonna do is, since I can't really code with an ice cream on my hand, we're just gonna watch YouTube videos, I guess. So let me just open Mozilla Firefox, which is not this thing. Let's just watch videos. Okay. What should I watch?
Hello folks, in this video I'll go through how to make a simple player character.
I'm live right now. That's cool. The fun way to learn programming. That'd be cool. So I edited my first video in DaVinci Resolve. Okay. Sure. Why you fail so quickly? How your brain picks your crush? I don't need that. What should I watch? Algebra slowly for sleep. Okay, that could be interesting. How to improve as an editor? Why not?
So, you're an editor, and you want to make good edits. But every time you start a new project, you lose motivation because the project takes too long, or you simply think it's not good enough.
That's literally me.
Well, what I've told you, it doesn't have to be like this. Because in this video, I want to give you some advice on how you can improve your workflow and get more enjoyment out of editing. My first piece of advice is don't overscope. From my experience, this is one of the easiest pitfalls to fall into. You might get an idea for a super cool 2-minute long edit that's cinematic and has a lot of effects, but while you might be motivated at the start, when you start editing, you realize how much work it actually is. Instead of jumping straight into these big projects, focus on making a lot of small ones first. If you can't consistently finish these small edits, the big projects are just going to be too over.
Yeah, it would be really cool if I could edit 1 hour per day. But it's not enough, right? Even if you do 1 hour per day, it would still take you like weeks. But here's the problem. If you don't edit at all, it won't be edited. Dude, you're not gonna share ice cream with us? Oh, you want ice cream? Do you know how much this ice cream costs? So it's 100 yen. So it's 100 yen in my country. So let me just like turn that to USD. It's 0.63 USD. Or in euros, it's 0.55 euros. Or in rupees, it's 57.91 rupees. And what other currency that I haven't? Canadian dollars. Canadian dollars. It's 0.86 Canadian dollars. Yeah, so it's cheap.
Overwhelming. It doesn't matter if they suck, just make them. I've made hundreds of edits, and some of them were good, but most of them were bad. And that's okay. I still learned from those projects, maybe consciously or subconsciously. If I didn't make those bad edits back then, I would not be able to make the good edits I make today. So once you get comfortable with creating these smaller edits, you can gradually work towards creating bigger projects. Which brings me to my next point. Challenge yourself. You only really improve when you step outside of your comfort zone and try things you haven't done before. If you keep doing the same type of edit over and over, you'll probably stay at the same skill level. With every edit, try to do something new. Whether it's an effect or transition doesn't really matter. It's about expanding your skill set. And you might not be able.
I think this doesn't apply to me. Huh. The art of beginning anyway. Okay. The weird world of indie social media. Okay. Oh guys, I have a new Discord server. Yeah, if you want to join, just go down below in the description and I have like the invite link. You could join the server, you know. I want to let you know. I spent 2 years developing my indie game. That could be cool.
2 years ago, I sat down at my PC, opened up Unity, and created a new project. It wasn't the first time I'd done this. In fact, I've lost track of how many projects I left unfinished over the last years. But like every time, I was convinced that this time I was actually going to finish it. I had the idea for this project for a while already. Crafting and exploration were always my two favorite parts in games. I never really enjoyed games that make you follow a strict pre-planned path. And after having created countless little endless runners and unfinished mega projects, I wanted to try making my own little crafting and exploration game. I wanted to keep the scope of the game small and simple, which worked great as you can see, since the past taught me how important it is to stay realistic with the project. Nonetheless, I sat down and started planning a bit before getting to work. There were some aspects I wanted to have settled before starting the game's development. The genre was pretty clear from the start. The crafting part was going to be pretty straightforward. You gather resources throughout the world and can process and craft them.
Sorry guys, I'm just eating ice cream.
With them that allow further processing and crafting. But the exploration was where I expected things to get tricky. You see, normally when it comes to exploration in video games, it's always associated with huge AAA title worlds that are filled to the rim with detail and content. But as a solo developer developing the game in my free time, I don't have the resources for that. I wanted the game to be a pixel art game. But I also wanted the world to have a 3D feel to be more immersive. My first idea was making the game actual 3D and using a pixel art shader when rendering it to the screen. I actually ended up creating a little test prototype for that approach. The problem was that I had absolutely no experience when it came to creating 3D assets, so I would have to spend hundreds of hours of making 3D models before.
I tried Blender before. It was really hard. And I swear I'm not gonna touch it again. So like I'm never going to touch Blender again because like it's so complicated. I don't know if it's a necessity to learn Blender, but you can go to different routes, you know? For example, if you're gonna make games, you're probably just going to make 2D ones with Photoshop.
Reaching a quality level that I was happy with. But over the last years, I had collected hundreds, if not thousands of hours making pixel art for my other projects. So I decided to go with isometric pixel art. It provided the mix of pixel art style with the three-dimensional depth that I wanted the game to have, while I didn't have to learn a completely new way of making game assets. Before I continue, I wanted to mention that if you like what you see and you want to support the project, consider wishlisting Isocore on Steam through the link in my description. I would really appreciate that. So I sat down on my PC and got to work. I started by creating some basic game art so that I had something to work with. Some blocks, a tree, and a basic player sprite. The second step was to create the player and get it moving. I created a tile map, filled it with some basic tiles, and wrote a simple character controller. But
Oh, he's using Unity for this. Wait, is that Unity? Or is that Blender? I think it's Unity, right?
WASD felt incredibly weird because of the isometric perspective. I tried a bunch of different key combinations, but nothing felt natural to control. After trying a bit around, I ended up implementing an A-star pathfinding algorithm that made the character move towards the cell that the player clicked on. These were the only controls that didn't feel weird with the isometric art style. Now that the player could move around, I needed to fill the world. I created some trees and stones to place them in the scene. However, the pathfinding algorithm needed a way of knowing which cells could be walked on and which not. For that, I created a second tile map that does not get rendered to the screen, but contains which cells are being occupied by an object. Further, I added a hit and hurt mechanic to make the player able to interact with objects in the scene. And of course, a simple inventory for the materials dropped by the objects. Now that you could run around the
2 years is a really long time.
world and interact with objects, I thought about how I wanted to shape the world. My initial idea was to separate the world into little islands that the player would have to unlock step by step. I was hoping that separating the world in these chunks would give a small world a much larger feel, since a smaller area had a much higher value compared to a large open world. The progress was going great, until the thing happened that always happens. I got bored and stopped working on the project for months. A couple months passed by when I finally decided to give the project a second try. Around this time, I made my first video about the project. It was my first YouTube video ever, and I had absolutely no idea what I was doing. The video showed how I implemented lighting and shadows into the game, improving the game's looks significantly in my opinion. While it didn't add too much gameplay value, it felt like a significant step forward, and I finally had fun working on the project again. The video only got about 50 views in the first month, but I was more than happy, and the little but positive feedback was awesome to see. However, not long after, I hit a dead end. The island-based world design did not feel unique or fun. I spent over a month experimenting around. I made the islands adding up as an area, I made them visible one by one, I changed the size and shape, I implemented multiple generation algorithms and different layouts, but nothing
That's complicated.
worked. There was no huge issue, but it just didn't feel fun to play in my opinion. I eventually decided to pivot to an open world format, which I initially wanted to avoid. I reused the pre-made chunks from the island system to create a simple open world loaded from a Perl noise function. Nothing fancy, but it did the trick. On top, I had also taken care of some other mechanics like a crafting and building system, as well as a provisional UI.
There is no way I'm just eating ice cream while watching a YouTube video, and I got like 5 people currently watching right now. How is that even possible? I'm not coding.
And some basic sounds, making the game feel a bit more playable. At that point, I decided to give the devlogs another try, and almost 1 entire year after the first video, I released the second one. I wasn't expecting the video to perform much better than the first one, and for the first 3 days, it didn't. But after 3 days, the video...
I'm almost done eating my ice cream.
...kept ringing from people leaving their thoughts on the game in the comments. People wrote what they liked, what they didn't like, and what they wanted to see. And happily, most of the people liked the pivot to the open world. The fact that I could see that people were actually interested in my game was incredible.
Wow, this game looks cool.
And at the same time, it also put a little pressure behind the
Wow, look at that lighting effects.
project, which was good for when I really didn't feel like working on it. people started to ask me when and where the game was going to be available. And one viewer pointed out to me that I was missing out on a huge amount of potential wishlists by not having a Steam page for the game yet. He was totally right, so I fixed it right away. Something I've also been asked a lot in the comments is how to get started with game development or what you need to make your own game.
This is a really high quality game right here. So anyways, let's actually just continue on coding. I finished eating my ice cream. So let me just like go back.
So you're
Hello folks, in this video I'll go through how to make a Hello folks, in this video
All right. So let me just like set up VS Code again. When you think about it, probably like a coding stream is not fun to watch, right? It would be fun to watch if someone's like coding, not coding really. If someone is like playing a game or like, I don't know, watching YouTube videos, but coding streams,
I'll be going
it's probably really boring. So anyways, I actually don't understand this. So they have print r1.test print and then r2.test. Okay, let's do that. So here just put print r1.test and then r2.test. And then let me just like run that, and we got nothing for some reason, because like I don't know what I'm doing. I know what I did wrong. This should be a circle. So instead of rectangle, it should be circle like this. So this should work. And we got an error for some reason. So we got an error on 6. Really? On 6? Because, oh, okay. What's 6, by the way? Here. This is 6. Okay. Let's go back here. Let's see what I did wrong. Require circle. We did require circle. Is it because like I didn't save this? I have saved this because that's fine. I have classic.lua, I have saved this, and main.lua, I have saved this. Let me like make sure that this is saved. So I'm just gonna save everything. And we still get an error. It says rectangle is an unknown thing. So somewhere, okay, this, you don't need this. It should be circle. Okay, I think this would work. And we actually got 2 numbers, which is cool. So we got 795 and 699. I think that's mission successful. I actually don't understand the code, but I think that's just fine. Let's read. When you run the game, you will see that 2 random numbers are printed. So let's go through this code by step. First, we create a new class with rectangle. This. Seriously? Okay, what if I just do this and then it wouldn't run, right? Yeah, we get an error. So we need this thing. And I think we need this object thingy. But what if I just do this? I think that's gonna do the same thing, which is it's gonna spit out an error. And here on circle.lua, it's called object something something. object.extend object. I don't understand that. First we create a new class with rectangle object.extend object. Okay, so this is basically creating the class. But I feel like I couldn't remember that. There is no way for me to remember that. This makes rectangle become a class. Which is circle in my version. This will be our blueprint. As opposed to properties, classes are usually written with an uppercase letter. So this will be upper camel case or Pascal case. Okay, I got that. So this is called Pascal case. Huh. Okay. Let me just like open Anki and let's put like the I'm not really familiar with the Pascal case, so I'm just gonna make a question for it. Let me just like add it. It doesn't show the add screen on OBS. Let me just fix that for a second. It does. Okay, so is it this? No, I don't think so. Render in place. That's weird that it doesn't show here. So I have because like okay, I think I got it. Is it showing on your screen, guys? Now I noticed that it doesn't have a shadow. So I'm just gonna go make one. Go to filters and then go to shadow. And then go make a padding. So we're gonna go do this. -30, -30, -30, -30. And then on the shadow, I can't see clearly. Okay, hold on guys. I'm just gonna make like a shadow for this add thingy. Okay, cool. And then I'm gonna go change the direction of this. So on the light angle, I'm just gonna make it there. And the distance, I'm gonna put a little bit of distance, and the size, a little bit of size here. And on the cropping side, instead of 30, I'm gonna make them all 40. Okay, that looks cool. And then let's just turn down the intensity. I think that's better. So let me just like go with that. All right, so I added the add thing on Anki. So here, we're just gonna go write a question. What in coding, what is this text format called? Table of rectangles in coding. This is called Pascal case. I think that's cool. I think it's called Pascal case. So let's just add that on Anki. And let's continue on to our coding. So this would be uppercase, upper camel case, or Pascal case. In main.lua, we say R1 equals rectangle, all right? R1 equals circle. Even though rectangle is a table, we can still call it as if it's a function. Okay, so if I go to circle, this is a table. Okay. I'm very confused. So this is uppercase in Pascal case. This works table. We can still call it as if it's a function. How that works is for another chapter. But by calling rectangle, it creates a new instance. What that means is that it takes our blueprint and creates a new object with all the class its features. Every new instance is unique. To prove that R1 is unique, we create another instance called R2. Both have the property test, but they have different values. When we call rectangle, it executes rectangle.new. Okay, which is this thing, circle.new, and we pass self. And then self.test. I still don't understand this. This is hard. When we call rectangle, when we call rectangle function, it executes rectangle.new. This is what we call the constructor. Okay. So if we call rectangle, which is in our case, it's circle with nothing in it. This is called the instructor. No, not instructor, the constructor. The parameter self is the instance we're modifying. If we were to type rectangle.test equals math.random 0 to 1000, we would be giving the property to the blueprint and not to an instance made with blueprint. I have no idea. Let's make some changes to our class. Rectangle. Okay, so this is in rectangle.lua, so I'm just gonna go to circle.lua in my case. And then here, function rectangle.new, self, and then we put these things. Okay, so where is that? So here. And then self.test, we need to just delete that. And here we go self.x equals 100, self.y is equal to 100, self.width is equal to maybe 40, and self.speed is gonna be equal to 100, and function circle.update, and there's gonna be two things, which is self and dt. Okay, self dot x equals self dot x plus self dot speed. Do we have self dot speed? I think we have it, times dt. Okay, and then we're gonna have function rectangle dot draw self love dot graphics dot rectangle line self x. Oh, we're not gonna do rectangle. Actually, it's circle in my case. And then here we go self dot x and then self dot y with self dot width. I think that's the code. It's like the moving rectangle object we made in chapter 8, except this time we put the code of the movement and drawing part in the object. Now we only need to call update and draw in main.lua. Okay, let's try to do that. So function love.update r1 dot up, not r1, oh, r1 dot update r1 dt. Okay, and then here function love dot draw r1 dot draw r1. Okay, I realized that you're using r1 two times, because like I think that's because if we go to circle here, it has this thing called self and you have to pass itself, so that's why. Because like here, if you look at the circle.update, it has the parameter self. So I think because of that, you have to put r1 here, which is very confusing. I think on this thing, you can do this. Instead of a dot, you can use colon. Is this called a colon? Well, what is this called? What is this symbol called? What is this called? It's, oh. What is symbol that called? It's called, it's not here. Okay, what about here? Oh, it's probably not there. It's called a colon. Then what is that thing called if it has like semicolon? Semicolon. Oh, okay. Now I know. So this is called a colon, but this thing is called a semicolon. Okay. Let's try to run it. We got an error. Of course we're gonna get errors. It's saying that we accidentally put rectangle somewhere. That's really bad. I got 127 subscribers right now. Thank you very much. So, so I accidentally put rectangle somewhere for some reason. Found it. What is this? is supposed to be like that. Okay, let's try to run it. We got an error. And what's the error this time? Did I try to save this? Yep, everything is saved. Let's try to run it again. Okay, so DT is trying to attempt okay. Oh, because I don't have DT here. Okay, so how does this work? Oh, it works. Would you look at that? That's really cool. Okay, so we got that working. I don't really know how the code works. So what we're gonna do is go here and create a new folder called random, right? And then in this random folder, I'm just gonna go have main.lua. This random folder just acts as placeholders for things that I want to try out, if that makes sense. So what we're gonna do is we're gonna try to do this again. So I'm going to hold on, I'm just gonna like do things. Okay. Current viewers 3. And then all right. So what I'm gonna do is copy this classic.lua. How do I copy it again? I think it's just C and V. Wait, what? I press P. That's cool. So in this here, in main.lua, I can go function love.load. And then inside this, I need to require, no, I need to do this first. So object is equal to require classic. Cool. And then add the code at the top of the file to require this file. I got like a suggestion. What is that? Mark classic as defined global. Control J. And apparently, I think this needs to be a string or it wouldn't work. And then in the random folder, let's put circle again. Circle.lua. And here, we're just gonna go and do circle is gonna be equal to object dot extend self. I think it's the thing we did. I don't remember. And let me just like do this. Okay. Let me just like go back and see. And yeah, we did this, but instead of self, it's just object dot extend object. And I want to try this. Instead of like object dot extend object, what if we do object colon extend? Is that gonna work? Yep, it works. So okay, so I'm just gonna use colon in this case. So colon and then object, which we don't need to write anything there. So here, function love.update. Yeah, I'm not actually referring to anything. I'm just trying to learn how this works by typing it again. So I think it was like function something. Function circle.load, was it? Or function new circle? I don't know. Let me just go back. So circle.new self. Wait. Oh, it doesn't work. Okay. So we need to put self here. In JavaScript, it's this. Hold on. In JavaScript, instead of self, we use the word this. But in Lua, we need to use self. Okay, so defining things. How do you define things, I guess? We can go with self dot something speed, something like that. Okay. Okay, so self dot pos is gonna be equal to a table that has x equals 200 and y equals 500. And then we're gonna have a thing called self dot speed. Then here we can have function circle dot update. Inside we can have self and then dt. Okay, so there we can update the circle. So I just want to update it so it's gonna go down. So self dot pos dot y is gonna be equal to self dot pos dot y plus 1 or 100 or self dot speed. Here I forgot to define the speed, so I'm just gonna go 150, and here we need to put the dt, so times dt. Okay, so when we do that, I think we're done with the update. Now we're gonna go to the draw function. So circle dot draw circle dot draw I think that's right, and we don't need anything there. We do actually need a thing. It's self. Okay. If we do that, we can do love.graphics and then dot circle. Why is it like capital letter? I don't think we need it to be a capital letter. Line pos dot self dot pos dot x and self dot pos dot y, and I'm going to like split this like that, and here I can go like the radius, which is self dot size, and we didn't define the size of the thing, so self dot size is gonna be equal to 50 or 90. Okay, we're gonna go like that. So I think this is valid code, so let's go to main.lua And in here, we're gonna write the draw function and the update function again. But this time it's love.2d. No, it's just love.update. How do you do this again? I should have forgot. I think first here we need to require circle, and after that we need to like create an object, which is, I'm gonna name it circle1, and then make that equal to circle with an empty argument. And here on the update function, I can just go like circle1 dot update, but this time instead of like dot, we're gonna make it colon update, because like that's gonna pass itself as an argument. And then we're gonna put dt here, and I always forget to put dt here. And I think that's it for the update function. And here we're gonna do the draw function, circle1 colon draw, and then nothing in it. I think this should work, right? So if I run this, we get an error. Attempt to index global circle to a function value. I don't know what I did here that's wrong. Circle1 requires circle. So it says the 12, which is this thing, is kind of wrong. And I don't know what's wrong with this. If I go here, circle.update. I don't know what's wrong. Okay, let me just like see what I did wrong here. So main.lua here, it's kind of the same. And then R1 update dt, R1 draw, circle1 circle is this, circle here, circle.new. Oh, I think I know what I did. I need circle.new here. Would you look at that? I need y to be 150. 150. And let's see. Okay, maybe like a little bit more down. Maybe I can just like divide this by 2, and then the speed, maybe just make it like 90 or something. Let's see. Cool. Now we've done that. I think I don't think I'm gonna get this. I'm probably just gonna go back to my method on just like storing all of my objects into a table and just making use of a for loop. But I think this has like some perks. For example, it hasn't been taught yet, but later maybe they would make it so you could call have objects have like functions. Methods is what it's called. So I'm looking forward to that. So we created a class called rectangle. We create an instance of that class called R1. So now R1 has the functions update and draw. We call these functions, And as first argument, we pass the instance itself, R1. This is what self becomes in the functions. Okay, that makes sense. So circle 1, if you do circle this, it's gonna call the function, which is this thing, circle.new. And what circle.new do is it assigns the position, size, and the speed. Now, these things now inherit circle 1. So circle 1 has those properties right now. So if I do circle 1 dot for example position, which it's gonna return the x and y values of that. Okay, and if we do this circle 1, it kind of makes sense in my head right now, but it's kind of hard because like we're using a library, and every time I use a library it seems like magic, right? Because like libraries are like a black box that you can use to make things easier. And since we have a library here, I don't understand why we need to use it. Okay, this is what self becomes in the functions. It's kind of annoying though, how we have to pass R1 every time we call one of its functions. Luckily, Luas has a shorthand for this. When we use a colon, the function call will automatically pass the object left of the column as the first argument. Okay, I have done this, so I don't need to learn this again. And we can do this with the functions as well. Oh, really? Did I do that? Really? So like, instead of circle.new and self, can I just like do this? Hold on. Is that possible? There is no way that's possible, right? What? That's possible? That's surprising. Now you don't have to put self when defining these class functions. This is really cool. Because like, it doesn't really make sense, right? If I do this, it doesn't have the self keyword here, but Lua knows to use self here. Lua knows that if I'm referring to self, it's referring to the circle. Actually, I don't understand. What is this? Draw, new, speed. Oh, I think this is like the things that he has inherited. Oh, that's cool. So let's go back. That's so cool. We call this syntactic sugar. What does that mean? Oh, it has its own Wikipedia. Really? In computer science, syntactic sugar is syntax within a programming language that is designed to make things easier to read or to express. It makes the language sweeter for human use. Oh, that's cool. I think one notorious language for using syntactic sugar is probably C++. I don't know. You can quote me on that and say you're wrong. Let's add some parameters to rectangle new. Okay. So self x equals x. What is Oh, okay. It's just putting like parameters. Okay, like let me just like modify the code. So self x is equal to x and self y is equal to y. And here we can go x and y. And I feel like if you have it, I feel like you can do this. You can put the or keyword and then put something here like 300 or 300, 200. So if I run this, it still runs, but if I don't put these, I feel like it won't run. It's gonna give us an error, I think. Yep, it's gonna give us an error. So it's best practice if you haven't defined the things yet. You should put or and R1, R2. Let's like define. Right now we're using only R1, so I'm just gonna go with 0 and 0. Which indeed is gonna go to 0 and 0. Okay, cool. So now we learned that. Thank you very much. Wow, classes are cool. I couldn't believe you can use classes inside Lua. With this, we can give R1 and R2 each their own position and size. Cool. They're using R2 as well. So we're going to do this. R2 here and then here. R2. I feel like you don't need to write this. Okay, let's try it. As you can see, we have 2 circles going to the right. That's really cool. So let's go back on sheep pollution and read more stuff. Function love.update. Okay, I read that. Now we have 2 moving rectangles. This is what makes classes so great. R1 and R2 are the same, yet they are unique. That's probably another not so great about classes. I think classes are great, right? It's kind of like the calculus of math, but if you could make use of it, it's super useful, I think. Inheritance. With inheritance, we can extend our class. In other words, we can make a copy of our blueprint and add features onto it. Oh my god. Without editing the original blueprint. We're gonna do inheritance? I don't even know the concept yet. Let's say you have a game with monsters. Every monster has their own attack. They move differently, but they can also get damage and are able to die. These overlapping features should be put in what we call a superclass or base class. They provide the features that all monsters have. And then each monster's class can extend this base class and add their own features to it. Let's create another moving shape, a circle. What about our moving rectangle and circle have in common? Well, they both move. Let's make a base class for both of our shapes. Create a new file called shapes.lua and put it in the following code. Okay, so I think for this, I'm gonna make a new folder. It's gonna be called 13. Can I open my windows, guys? I feel like the room is like full of CO2 and my brain is like not functioning properly. All right, I have opened my windows. So 13 is all about inheritance. Inheritance, is that how you spell it? Inheritance, I think that's how you spell it. So inside this, we're gonna have main.lua, and here we're going to have class.lua, or we're gonna just copy and paste. So we're just gonna have shapes.lua, and then here we can copy like the classic by doing y. Wait, what? By doing y and p here, or maybe it's c p. Okay, let's close this, and in shapes.lua, what do we code? This thing. So shape.new, shape update. Okay, so let me just do this, and then shape is gonna be equal to object extend, and then shape. No, we need it to be a function. Shape colon new self dot x is equal to x, and then y is equal to y, and then we're gonna have x and y here. Okay, and then here we're gonna have self dot speed, it's gonna be equal to 100. Okay, and then we have the function update. Okay, so function shape colon update, and self dot x equals self dot x plus, how do you, okay, plus self dot speed times dt. Okay, our base class shape now handles the movement. I should point out that base class is just a term. Base class is just a term. What do you mean? X is a base class of Y. A base class is still the same like any other class. It's just different in how we use it. Okay, it's just a term. Anyway, now that we have a base class that handles our movement, we can make rectangle an extension of shape and remove its updater. Make sure to require shape before using it. Okay, so we need to do require first and then require rectangle. So in the main.lua, I haven't coded things yet here. So function love.load, here I want to require shape, and then let's make a new Lua file that's called rectangle.lua, and here we're gonna require this thing, and we're gonna put the rectangle. Okay, so again we're gonna have r1 equals rectangle We haven't defined rectangle yet, but I'm just gonna make, I'm just gonna put it as a placeholder. Okay. Now this should be 2. Okay. Now we go to rectangle.lua, and inside this thing, we go, let's do this first. Okay, rectangle is equal to object colon extend and nothing here. And after that, we can go function rectangle dot new, and this should be a colon, so we don't have to put self. All right, so hold on, let me just like check my stream if everything is good. I feel like everything is good. We have our mic. If I play audio on my desktop, would it like, you know?
Through the fundamentals of programming.
Yep, that's cool. I think we're good. Yep, we're good, I think. So rectangle new, and in this rectangle new, I'm going to, what is this? What is this? What is this? Rectangle dot super dot new? What is that? Why is there super? So wait, what, why? Okay, the self keyword came back, X and Y. Okay. Self on this new thing, it's gonna have X, Y, width, and height. Oh, this is super confusing. Okay, so that width is equal to width, and this is height. Okay, so we're gonna make a draw function for this. Function rectangle colon draw, and then love dot graphics dot rectangle line self dot x self dot y, and then self dot width and self dot height. Okay, let me just like split this into multiple codes, and then maybe split it here as well. Okay, so that's that. That was really shape extend. Oh, I noticed that this is different. So this is supposed to be object, but now it's shape for some reason. So let me just like go with shape here. Okay, so that's shape. And then we got rectangle dot super dot new self xy. And what the hell is super? I don't understand. Okay, let's go back. Let's read. With rectangle equals shape colon extend, we made rectangle an extension of shape. Okay, that's cool. Shape has its own functions called new. Yeah, we know really. Hold on, shapes. Yeah, it has new. Self x, self y. Okay, I'm very confused, guys. What is this? In rectangles, What is going on? New. By creating rectangle new, we override the original function. Okay, so this is just overriding the thing. So normally it's shape, but if you go rectangle new, it's just going to override it. Okay, override it with this. Meaning that when we call rectangle, it will not execute shape new, but instead rectangle new. Okay. But rectangle has this property super. Where? Rectangle has the property super. Where is the where is that? I don't see the property. Okay. Which is the class rectangle is extended from? The class rectangle is extended from. Where is super? Okay. Here we have super here. But I don't see super anywhere. Okay. But rectangle has the property super. I think it's just defining, but I don't understand. Which is the class rectangle is extended from. With rectangle super, we can get access to our base class function, and we use it to call shape new. Is this super thing inside classic? Yeah. Would you look at that? You have cls.super self. So super is the thing you use to access the base class. In our case, the base class of rectangle is shape. Okay? And then we're just we are going to call it, we're gonna go call shapes new function, which is gonna do this. Oh, okay. And then why do we do that? To pass self. I think I can just do this. I think this works, right? I have no idea, but I feel like this works. We're gonna pass xy to shape. That makes sense. And then self.width is width, self.height is height. On the shape, I don't think we define width and height. All right. This is so confusing. We can get access to our base class functions, and we use it to call shape new. Okay. We have to pass self as first argument ourselves, and can't let Lua handle it with... Oh, really? Because we're not calling as the instance. Oh, so this is not valid? Okay, let me just like do this again. Okay, self. Okay. Because we're not calling the function as the instance. Okay. Now we need to make a circle class. Okay. Create a new file called circle.lua and put the following code. This is so hard. So circle.lua. Okay. Circle.lua. And then what should I put? I should like copy and paste. Not copy and paste, just like type it. So shape extend dot dash dash, and then function circle dot new or colon new, and x y radius. Here we go, circle dot super dot new self with x and y. So self dot radius is equal to radius. And then we're gonna make this have the function circle dot draw, and we need this to be a colon, and then love dot graphics dot circle line, and then self dot x, self dot y, and then self dot radius. Okay, let me save that. Okay, that's cool. So we make circle an extension of shape. We pass x and y, which we did, to the new function of shape with circle.super.new. We give our circle can we change the code of classic? Because I'm not really familiar with super. Like instead of super, we just call it base. Is that possible? Is that not possible, guys? I don't know. But we're gonna use super. Okay, so let's go back. Okay. With how they have radius, and now in main.lua, load shape.lua and circle.lua and change R2 to a circle. Oh, but I have to like, okay. Let me turn this into a circle then. Circle. And then we require shapes, which we did. Oh, I forgot object equal require classic. I forgot that. Require shapes. Okay, require rectangle. Let's actually rename this to shapes. No, never mind. Let's rename this to shape. And then this R, just remove the S, press enter. And here, R1 is rectangle. Oh, we forgot to require circle. Okay. And then when we have that, do these. Let's go back and go to main.lua here. And I'm just gonna copy the code here. Main.lua p. Okay, does this work? Of course we're gonna get like an error or something. Of course. There. Okay, so attempt to perform arithmetic on field X. Okay, 13. We got a problem on 13. So love.update dt, and we pass dt on these things. Okay, let me GCC this, and let's try it again. Okay, 13 again. So there's something wrong with 13. This thing is wrong? How is this wrong? I don't think this is wrong. GCC. Okay, we got a on 13 rectangle number expected got nil. On rectangle number expected. Did I save everything? I did. Okay. So I made the Lua. Let me GC this to bring it back. R1 rectangle. I know why. I think because I did specify the coordinates. We're gonna have, for example, 100 here and 0, maybe around 200 here. And here we get 100 and 400. And for the size, how do we, let me just like go to circle. It says here radius. How about on the rectangle? Width and height. Okay, so let's do that. On the rectangle, I'm gonna go put like 100 and 100, and this is just the radius. So I'm just gonna put one, another one argument, 70. Okay, let me run this. Wait, hold on. Let me just like run this again, and I forgot to like uncomment this. So let's do this again. Now it works. And here's the problem. I don't understand this. And that's a problem. There is no way I'm understanding that. Inheritance? Wow. It's so freaking hard. Oh my god. I think I used like the full capacity of my brain. There's no way I'm learning this. But I think it's like good practice though. If you learn this, it will be easier to make games. And this could be applied to many other programming language or any games, any frameworks, any libraries. The framework where, oh, what is the difference between a framework and a library? Because like Lua is a framework, and here they said that Classic is a library. So they must be different, right? I always thought that like the framework and library are like the same thing, but I don't think that's the case. But anyways, let's go back. Okay, I actually got the thing moving one more time. Let's go through all this code one more time. Oh my god. First, we load the library classic with require classic. Loading this library returns a table, and we store this table inside object. Very hard. It has the very basics needed to simulate a class, because Lua doesn't have classes, but by using classic we get a very nice imitation of a class. Next, we load shape.lua. In that file, we create a new class called shape. We will use this class as a base class for rectangle and circle. The two things that these classes have in common is that they have an x and y property. That's cool. And that it moves horizontally. These similarities is what we put in shape. Now imagine classes inside classes inside classes. It's gonna be a nightmare. I don't want to code that. Oh my god. Coding is not fun. Next we create the rectangle class. We make it an extension of our base class shape. Inside the colon new parentheses function, the constructor we call the constructor of our base class with rectangle.super.new self xy. We pass self as the first argument so that shape will use the instance of our blueprint and not blueprint itself. We give our rectangle a width and class property and give it a draw function. Next, we repeat the above except for a circle. Instead of width and height, we give it a radius property. Now that we have our classes ready, we can start making instances of these classes with R1 rectangle something something. With these arguments, we create an instance of our class rectangle, it is an object made out of blueprint and not the blueprint itself. Any changes we make to this instance will not affect the class. We update and draw this instance, and for that we use the colon. This is because we need to pass our instance as the first argument, and the colon will make Lua do it for us. And finally, we do the same for R2, except we make it a circle. There's no way I'm learning this. This is so hard. Yup. Confusing. There is, if you're an absolute beginner, I don't think you can go through this. There is no way you can do this first try. Like, for example, if you're a normal human being who don't know how to code any code, don't know how to code any programming languages, there is no way you're getting through this. I feel like people would just quit here, because like me, holy, that's a lot. That was a lot of information for one chapter, and I can imagine if you're having a hard time understanding all of this. My advice, keep following the tutorials. Tutorial hell. If you're new to programming, it will take some time before you get all of these new concepts, but eventually you will get comfortable with them. I will keep adding explanations on older subjects while talking about the newer ones. Okay, let me just like search something. Does the game Undertale use classes? No. No, not classes. OOP classes is what I meant. Different game studio scripting language one has since put more direction OP coming to be flex protection. Did not rely heavily on structured OOP classes. Massive if, else, and switch statements. Dialogue, scene, management, and battle system are often handled by giant nested conditional statement rather than a clean abstracted object-oriented class. Wow. Procedural scripting. Rather than using inheritance or encapsulated classes for enemies or items, much of the logic is coded directly within objects, which some analyses have described as disorganized or unconventional bad programming. Performance workarounds. The game handles these inefficient structures well because of the engine's capability, managing complex interactions without significant lag, despite not following the typical software and engineering best practice for structure. Yeah, I think so. That's cool. Doing it properly. In this tutorial, I use globals to make things easier. However, a more proper way will be to use locals. We do this by changing the class in two ways. We make the class a local variable in the file. We return the variable at the end of the file. Here's how we should change shape.lua. Okay, I want to change this because this is gonna be. This actually confused me because like I had to use object. What I'm more familiar with is this, which is M. Big letter M. Hold on. That's not right. I should not change it here. Hold on. Can I like use E? Okay, so like I reverted that. So, okay, instead of this. Oh. How should I? Okay. Never mind. We're not changing it to an M. We just need to make it local. Local, circle, and then return circle. And then on the rectangle, we're gonna do the same thing. How do you actually? Okay, I think it's just Shift I, local, and then Shift G to go to the end. Okay, and then return rectangle. Okay, and then on the main, what should we change? I think when we require, we're gonna do this. Oh, okay. Then inside the other files of the classes, we require the shape. Local requires shape. Okay, so I'm confused, but I think what it's saying to us that we need a local shape here, and then we need to require shape. And we need this, oh god, local shape is gonna be equal to require shape. And then, okay, that's cool. Cool. And then on the shape, we also need this to be local. And then Shift G. And then we are gonna put return shape here. I forgot to put, okay. And then on rectangle, we need to put local shape is equal to require shape. And then on the main.lua, we're just gonna do we even need shape here? I think we do. This is hard. Okay, so I think what we can do is, I'm confused. What they on main.lua, what do they require like classic? They don't even need the shape. So I can just delete this. Here, I can put rectangle is gonna be equal to this, and then hold on, this needs to be capital, and then circle is gonna be equal to this. Now will this run? It does run. And Prettify, what did you do? What is this? This is unhinged. It does look really clean, but what did you do? Is Prettify even on? Did Prettify did this? Okay, let me try and see if I have Prettify on right now. So I'm just gonna go here and find Prettify, which is we're using right now. So okay, let's go back. The code works. Cool. We could also move object require classics to shape the Lua and make it as a local as well. R1, R2 could be also made local variables, but they will need to be made outside of the load. Local R1, R2. By making these variables R1, R2 are no longer global. So we need to do that. Oh my god. Okay, so so I'm trying to understand this thing. Okay, so what we can do is outside of this, we're gonna put local R1 and R2. Now I don't think I can remember this, so I'm gonna put this to Anki. Let's add a new card, and we're gonna type in answer. And here I can do, let me just like take a screenshot of this. Let's take a screenshot of this. Okay. And then put it to Anki But before putting it on Anki, I'm gonna cover it like that, and then save the image, copy, and then on Anki, I can paste it. And before that, I would type something. I need to cover the whole thing. Okay. Copy that, delete this, and let's like, oh, whoa, that's weird. Okay, never mind. So I'm gonna put like define R1 and R2, but define var R1 and R2, but don't put initial values yet in Lua. And then we're gonna put the image and then the answer. Oh, I don't know why it's not showing. Okay, this is a problem. This is a problem. I don't know why. It's not showing the Anki. I'm having problems with Anki right now. I'm having problems. Okay, what if this is like computer? Doesn't solve the thing. Okay, so Anki add-on. Anki add, okay. And then this is not showing it. Now it's showing it. Okay, so inside of this, I would probably put local R1 R2. Okay, let's do it like that. So let's go back to sheep pollution, I think. Oh, do we need to like, does this run? Okay, so let's save this leader RR to run it. And then we see like the rectangle and circle is running. That's cool. Let's go back to this. This might seem like a lot of extra work for the same result, but your code will be much cleaner. Imagine creating a game with a global score variable, but in your game is also a minigame with its own score system. By accident, you could override the global score variable, and you end up confused why your score is not working properly. Globals can be used, but use them sparingly. Summary. Classes are like blueprints. We can create multiple objects out of one class to simulate classes. We use the library classic. You create a class with class name object extend. You create an instance of a class with instance name class name. This will call the function class name new. This is also the constructor. Every function of a class should start with a parameter self. So that when calling the function, you can pass the instance as first argument. Instance name, function name, instance name. We can use colons to make Lua do this for us. We can extend a class with extension name, class name, extend. This makes extension name a copy of class name that we can add properties to without editing class name. If we give extension name a function that class name already has, we can still call the original functions with class name super function name self. By using local variables, our code will be much cleaner and easier to maintain. Cool, cool, cool. I'm just going to close the windows, guys. Hold on. Oh, the stream is not doing well for some reason. I wonder why. But anyways, let's go back to our 12 lesson. Okay. Images. Whew, we're going to images. This is gonna be a hard one. The thing about this class lesson is that I feel like it's so advanced that I'm not yet ready to like take it. What am I talking about? Creating and adjust and using images is a very easy task in Love. First, we need an image. I'm going to use this image. Can I like copy this? Copy image. Go here. Can I P this? Nope, Control V this. I can! That was really easy. That was really easy. But we don't want it there. I want to make a new folder. Not there. GG. And then Shift A. 14 images. Images. And then do that. Press X. Put Y. Okay. Main.lua. And let's try to learn images. I'm so excited for this one. I wonder what we can learn. Okay, so of course you can use any images you like as long as it's a type of PNG. Okay, cool. Make sure the game is in the same folder as your main.lua, which I'm doing it right now, yeah. First, we need to load the image and store it in a variable. For this, we will use love.graphics.newImagePath. Pass the name of the image as a string as first argument. So if you have a, okay, a, cool. So here, YYPP, and then function load. Sorry, it's love.load. And then here, we can go my image is going to be equal to love.graphics.image. Okay, actually new image. New image, and then the path name is just called image, I think. Oh, you need to put the PNG. Image.png. Cool. You can also put your image in a subdirectory, but in that case, make sure to include the whole path. I think I'm gonna do that. Images. I'm going to make a new folder called images. And then xp main.lua go. Oh, it doesn't work. Go to main.lua. And then fi. And then we're gonna do this, which is images.png. Cool. Okay, now our image is stored inside my image. We can use love.graphics to draw to our image. Let me just like check if our stream is doing fine, because I did check if it was doing fine. Okay, so both are live. I'm going to like see the short form. The short form is healthy. It's excellent. Okay, so the short form is cool. How about the horizontal form? The horizontal form, it says excellent again. So I think we're fine, guys. We're fine. Okay, so I'm just gonna put that aside. And then I don't think we have new comments. So I think we're fine. Okay. And then, okay. So now our image is stored inside my image. We can use love.graphics.draw to draw our image. Cool. Let's try it. Function love.update. Not update, I need it to be draw. And then love.graphics.draw. And then do I just put like my image here? Cool. He or they set it to 100 and 100. And let's see if this works. Oh, will you look at that? We have sheep. Is this a sheep? I don't know if it's a sheep. Maybe if it's a sheep. I have no idea what animal this is. And that is how you draw an image. That was really easy. I was surprised on how easy it is. Really surprised. Draw arguments. Let's take a look at all the arguments of love.graphics.draw. All arguments beside the image are optional. The image you want to draw. The horizontal and vertical position of where you want to draw the image are the rotation or angle. Wow, they even give you like the rotation. What is this, radian? What if I go 360? Is this radian? Oh, I think this is radian. Hold on. Mat.pi. Oh, hold on. If I divide it by 2, how does this work? I forgot how radian works. I feel like 2 pi is basically the same thing as where it started. I think it went okay. And what's the other thing? If we divide that by 4, which is 2, I think this is in radians. Okay, what else? We have X scale and Y scale. If you want to make your image twice as big as you do, you're gonna do 2 and 2. Okay, cool. So 2 and 2. But here we're gonna put 0 because we don't want any rotation. Okay, so let me just run that and it will be twice as big. Yep, it is. Since it's twice as big, as you can see, it's twice as bad quality. All right. So cool. You can also use this to mirror an image with this. Oh, that's so cool. I'm gonna mirror the Y position. So this is gonna point up. You can't see it's pointing up. Let's put it to like 200, Y200 or something. I think more. Maybe 300. Okay. Okay, that's cool. That's cool. OX and OY? What's that? The origin, X origin and Y origin of the image. By default, all the scaling and rotation is based on the top left of the image. Cool. This is based on the origin of the image. If we want, it's basically the anchor point, right? If we want to scale the image from the center, we'll have to put the origin in the center of the image. Okay. Whoa, KX and KY. Did I get a notification of something? Okay. Mm-hmm. Okay, that's cool. You can skew images? Is that even useful? It would be useful if it's, I don't know. You know those games where they're wacky and they're like skewing things? That could be cool. Or you can have like a dragging. If you drag an object, it would automatically skew. I think that's one good use of it. That's actually cool though. Mm-hmm. X, Y, R, S, X, S, Y, O, X, O, Y, K, X, K, Y. Again, all these arguments except image can be left out. We call these optional arguments. You can learn more. Okay, look, you can learn about love functions by reading the API documentation. Image object. The image that love.graphics.new image returns is actually an object. Okay, an image object. It has functions that we can use to edit our image or get data about it. Okay. For example, we can use getWidth. We didn't get a new image. Nope. Chat. We can use getWidth and getHeight to get the width and height of the image. We can use this to put the origin in the center of our image. Oh wait, what? Get width and get height? Oh, that's really cool. Oh, we're going to like advanced territory. Oh my god. Can I put this to Anki, guys? I feel like okay. So let's go here and go to width. Width is gonna be equal to my image. Get width. I feel like you don't get auto correction for these things. Auto, okay, it's fine. Height is gonna be equal to my image, and then get height. Okay, that's cool. I feel like we should put this to Anki. Okay, let's put this to Anki. I just took a screenshot about it. And then I'm gonna cover up the get width. Hold on. The fill is gonna be this color for this thing. Get height. And then get width. You know what? Never mind. Okay, I'm just gonna copy this and then put this to Anki, which I hope that you can see, guys, and you can absolutely see. Cool. So here I can do something like put the width of the image in the variable in love 2D and put the image here. And the answer would be get, wait, actually not the width, it should be the height, right? So height, and then get height, and then like that. Oh, this should be like not capital here. Okay, that's cool. Okay, let's put one more thing. For example, hold on, I might become silence, guys. So Windows N, oh, the images just got like deleted or like they're gone. Okay, let me like snip this, and then what I'm gonna do is like cover up the thing that I wanna know, and just like that. Okay, copy it, close it, and then put it to Anki. And here, I'm gonna put something like, what should I put? Get load put image put png file to variable my image in love 2D, and then the answer would be graphics dot new image. I think that's it. Graphics dot new image. Cool. Let's add that and then forget about it. Okay, that's the only thing that I'm concerned that I'm gonna forget, so I'm gonna put that to Anki first. You have color for some reason. What does color do? I wonder what color does. Oh, did I just change this? Okay, let me just revert that back and then save the thing. Leader RR to run it, and we got the same result as the previous one. Color, you can change in what color the image is drawn. With Love the Graphics Set Color RGB, it sets the color for everything you draw. Really? So not only images but rectangles, shapes, and lines as well. It uses the RGB system. Although this officially ranges from 0 to 255 with Love. With Love, it ranges from 0 to 1. What? Are you serious right now, bro? 0 to 1? So instead of 255, 240, you would use 1, 0.78, 0.15. Why? If you only know the color using the 0 to 255 range, you can calculate the number you want with this. Makes sense. 255, okay. There is also the fourth argument A, which stands for alpha and decides the transparency of everything you draw. Don't forget to set the color back to white if you don't want the color for any other draw calls. You can set the background color with love the graphics that set background color equals RGB. Since delay. Love the graphics set background color RGB, and since we only want the it once, we can call it in love.load. Function love.load. My image. Okay, that was like a lot of information. And wow. Let's actually use this width and height to set the image's position. So can I just like do this? Okay, so HE, 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 and then we're gonna go do that. And then, okay. Oh, I'm dumb. Sorry guys. It's not supposed to be that way. This is like the width and height of the image, not the width and height of the window. I'm sorry. This is a really long code. Since we want to call it once, we can call it in love.load. Okay, call it once, background color 111. So we just do what? Hmm. Okay, so we're gonna do love dot graphics dot background. Nope. Set background color to 1, 1, and 1. Oh, we have white now. I didn't like the black background, but with the black with the white background, with the white background, I like it better. Function love.draw set color graphics set color to this, love.graphics set color to this, or love.graphics draw image 100 100. I don't feel like writing that. Let's just do it. Okay, so how do I do this? Okay, so love dot graphics dot set color, and then we're gonna go 1 0 0.5 0 0.5. What will happen? Oh, we got a red sheep. Cool. We got a red sheep. That's cool. Oh, that's the end of the image. I think I should do one more and end the stream. I don't know, guys. I was thinking to make Love 2D code, and I want to put it on my phone. Like run Love 2D on my phone. I was thinking on doing that, and I don't know if it's possible. There's absolutely two options if you want to run it on your Android phone. One is like the APK, where you take the love.love2d file, which is just .love, and convert that to APK. And another way you can run love2d files is basically download the interpreter, download love2d on your Android phone, and make that run your love2d. That's the two ways how you can run love2d things. We can use love.2d set color range in what color image else is drawn. Okay, so I'm just gonna go to the index and let's see. We're done with images. Oh, we're gonna be detecting collision. Oh my. I'm close to like finishing it, and I hope I'm gonna be finishing it. How many chapters? Okay, 24, and I've done like 12. Okay, so like we're really close. Are we close? we're kind of close. So we have like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have like 12 lessons still to go. Oh, so like we're in like the middle of it. You know what? Let's learn collisions. Why not? Detecting collisions. Let's say we're making a game where you can shoot down monsters. A monster should die when it's hit by a bullet. So what we need to check is the monster colliding with a bullet? We're going to create a collision check function. We will be checking collision between rectangles. This is called AABB collision. So we need to know when do two rectangles collide. What does AABB stand for? What is AEBB collision? It's called axis aligned bounding box. What? Hold on. I'm gonna put the donkey. Guys. So deconstruct AABB in English. Love 2D. And then it's called axis align bounding box. Okay, sure. And then the code for that is this. What the hell? Is a fast, efficient method used for 2D, 3D transformers in basic physics. I don't think I feel good. I don't think I feel good, guys. What is this? This is too much math. I created an image with 3 examples. It's time to turn on what programmer brain if you haven't already. What is going on in the third example? That isn't happening in the first and second example. Okay, so the first and second are not intersecting, but the third one is intersecting. Yes, they're colliding. Okay, yes, but you have to be more specific. We need more information the computer can use. Fine. Oh, this is so hard. Okay, we need to be more specific. Okay, so for example, let's think in the y direction. Okay, this, if it's not colliding, then red y bottom should be more than blue top line, if that ever makes sense. That's why I don't really like these things, because it's kind of like complicated. I used to code these things before, and I know for the fact it's really hard. Damn. They're colliding. Take a look at the positions of the rectangles. In the first example, red is not colliding with blue because red is too far to the left. If red was a bit further to the right, they would touch. How far exactly? Well, if red right side is further to the right than blue's left side, this is something that is true for example 3. But it's also true for example 2. We need more conditions to be sure there is collisions. So example 2 shows we can't go too far to the right. But how far exactly can we go? How much would red have to move to the left for there to be a collision? When red left side is further to the left than blue's right side. I'm reading these things, but I don't know a single thing. So we have 2 conditions. Is that enough to ensure there is collision? Well, no. Look at the following image. This situation agrees with our conditions. Red's right side is further to the right and blue's left side. Yeah, that makes sense. Because like the right side of this thing is further than this side of blue. So that means our condition was right. Our condition is right. So like, but like it's not colliding. So it shouldn't be right. So there's more to this. Okay. And red's on the left side, yet there is no collision. That's because red is too high. It needs to be moved down. How far? Oh my god. Till red's bottom side is further to the bottom than blue's top side. If we move it too far down, there won't be collision anymore. How far can red move down and still collide with blue? As long as red's top side is further to the top than blue's bottom side. Now we got 4 conditions. Are all 4 conditions true or these for these 3 examples? This is true, and this is certainly true. Okay, red's right side is further to the right than blue's left side. Okay. Red's left side, which is this one, is further to the left than blue's right side. Red's bottom side is further to the bottom than blue's top side. Red's top side is further to the top than